Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. The students will today deal with the binary search tree delete operation. So we're going to remove the node, okay, from the binary tree. So it's going to be very complicated, and we got to see all the scenarios. So firstly, it needs two operations. First is to search the node to remove, because you want to remove a node, and you're going to see whether that node is in the tree or not in the first place. Then only then you can go forward and use a remove algorithm to remove that node. Okay, when you remove a particular node, you got to actually think about the links, because you have to adjust the links. That is the problem here. Okay, so we have the first scenario where a node to be removed has no children. So it happens to be a leaf nodes, for example. Okay, say for example we got a tree structure like this. Okay, let me get a pen quickly. Now we have, say for example, we have excuse me. So okay, for example, we got this tree. We got a 20 on here, and then we got so let me make it in a proper way. Okay, this is a 20 here, and with two links, the left link pointing to this one, and it got to be lesser than 20. Say maybe it is the 10. Okay, and say it is a left node, right node. Its left node is having another node, say for example, which has the 5 in it. Okay, and there is a null in it, so it's a leaf node. And this guy is having a 15 here, for example. Okay, and there are nulls here, so that's a leaf node. And there are other trees also here, so maybe other nodes here, 30 for example, and on this side we're gonna 35 and so on, and these are nulls. Now if you want to remove whatever the tree is now, that could be, you can imagine, but what I'm saying is now you're gonna remove the leaf node. So if you want to remove this leaf node, for example, so only thing is you got to put up here null and delete this node, simple as it is. So free this memory, isn't it? So there's nothing to do much about in this. Only thing is you gotta go ahead and put up the null on a parent okay, link of that node. The parent link is to be put the null, and go ahead and delete that node. Now second case scenario can be that we want to delete someone which has a one child. Okay, for example, in this example you want to delete the 30 which has a one child, that is 35. Okay, now you can do it in two ways. Either you do one thing, you delete the 30, go ahead and link this 35 with here with the parent of the 30. Okay, now in that case 30 will be gone. Now the 35 will be the child of the 20, right child of the 20. Okay, that's also working fine, but that will be more complicated. A simple thing could be you just firstly do what, don't do this linking, but copy this 35 here. Okay, so now you have a 35 in this parent. Now we have two nodes to 35, and go ahead and delete this. Okay, now you can do it in this way or that way. So in first way I said you delete this node and link the child, that only child, whatever the child is, left or right, to the parent of the parent. Okay, to the ancestor. Okay, to the grandfather of the child. Okay, or you copy this 35 here, okay, to the parent and the key value, and go ahead and delete this only child, whether it's a left child or right child. Now the most complicated scenario will be when you want to remove a node which has two children. Now this can be solved using two methods. Either we use in order successor, okay, or we can use in order predecessor. Now I'm gonna use the in order successor. Okay, what does that mean is let me first draw a tree. Now for example, in this tree you want to delete, say for example, 15 or the 2 which has two no children. Now here we can't link, should we link 8 with the 7 or should we link 20 with the 7? What will happen? Okay, so what we do is we find the in order successor. Or what does that mean is we actually find, so the first thing we do here is find minimum value in the right subtree. Okay, the right subtree. So if you want to delete the 15, for example, so you want to delete the 15. Now in order to delete 15, you got to first find the minimum value or in order successor, that is the minimum value in the right subtree. So in the right subtree is from this tree. Okay, among this tree you got to find in this subtree, right subtree, the left subtree, this is the 8. In the right subtree you want to find the minimum value. Okay, that's the min function you can see, because min always go on the left side. Okay, so once you are done in finding the minimum value in the right subtree, that happens to be the 18, right? That's the min function which we talked about earlier. That's simple. The min function will go which make the pointer to go to the left until it's null. So there may be many other nodes, but the lesser one will be the leftmost. Okay, the minimum value. Now you found the minimum value, that is 18. Now next step is to copy actually your, let me change the different pen, this 18 into here. Okay, change the value of 15 with the 18, so you don't have to delete the 15 at all. Keep it there, so no need to change the links. Only thing is, this is very simple thing. Now you copy 18 here, right? Now once you copied 18 here, now we have duplicate 18, two nodes with the 18. So what you do is, now you go ahead and remove this node. Okay, now this removal of this node is simple. That is the first case, removing the leaf. Only thing is, you put up the null here in its left child, you put up the null. Okay, on this child's left entry you put up the null. Simple. Now this becomes very simple, right? Now there may be another scenario wherein we don't have the left child. Okay, so for example, I am saying that there is a, now scenario is like this. Now you want to delete 15. Okay, so you want to find the minimum value in the right subtree, and the minimum value this time is the 20. Okay, which does not have a left subtree. Okay, so that means you will copy 20 here. Now you have 20 on two nodes. Now you want to delete this node, but you don't have to worry about, because you have done already the case, the node removed which has one child. Okay, so this is a case where you delete a node with the one child now. Okay, because you have in your when you design a code, you have a piece of code which will delete a leaf node, then you have piece of code which will delete a node with a single child. Okay, now when you are calling create trying to delete the node which has two children, then what you do is you find in a right subtree the minimum value, that is this time 20. Now this comes a scenario where you have a node with the one child. Okay, so you first only do additional thing you do here is copy this 20 to this node. Okay, and go ahead and call this code snippet which will delete you this node. Okay, how? By linking the 30 with the with the abo node, or because this is now here 20. Okay, or the 20 node, or it will copy this 30 here. Okay, and go ahead and delete this using the only this one, deleting by the single where you have no children, using that code snippet. Does it make sense? Okay, so overall we said that if we have a leaf node, you got to only put up the null in the parent. Okay, and if you got a one child node with one child, you want to delete that, copy the value of the child into the parent. Okay, and delete this node as like you delete the leaf node. And third thing, I'm saying if you got two children, okay, find the minimum value in the right subtree or in order successor. Once you are done, then there may be two sub cases. Either that will come up like we saw here, we had a node here. Okay, in that case you copy this to the node to be deleted, and you delete this like you delete the leaf node. Or if you have no left left node to the child of immediate child of the node to be deleted, then that node itself will be the minimum. Okay, now copy that to the parent and delete this like you deleted the node with the one child. Okay, how you did that? You copy this to here, okay, and you go ahead and delete it like a leaf. Right, now let us try to see this all scenarios in a code. So this is our code snippet. Okay, this is my method which will delete the node, and we have a key which node to delete is in a key, right? Okay, the first case is if the root is null, the tree is empty, so we're gonna return, so there's nothing to delete. And now we're gonna see if whatever we're gonna delete is on the left or on the right. Okay, depending on that, if key is less than root arrow key, so we're gonna on the left side. Okay, we call the delete itself, we call it itself, and send it this time root arrow left. Okay, and with the key, and when it returns it, that will go into the root arrow left. That will act as a parent now. Okay, if it is greater than key is greater than root arrow key, then I'm gonna go for the root arrow right. These things are explained in a lot of times now. Excuse me. Now if key is same as the root's key, that means this is a node to be deleted. Okay, then what we're gonna do is we have to see whether we have a one child or no childs, or we have a two child. Okay, if we got the no child, then this will come null, this will also come null. Okay, and if we have, say for example, only one child, out of the one will come null. And what I do there is if the root arrow left is null, if I don't have a left node, okay, at all, then I should go to the right. Okay, and I will free that that node. Similarly, if I if my right is the null, if root arrow right, now wherever I am and its right, say for example I'm here and its right is null, okay, there is nothing here, then what I do is what I mean is I have a node on this side and I don't have a node on this side. So firstly I will have a temporary pointer, okay, which can point to a node type. That's why struct node, it is of type struct node. That means the pointer should be of same type which the node is of, and the root will be that this time here. And if I am going to delete this guy, right, if I'm going to delete this guy, then I need to keep the address of this guy before deleting this. So I'm saying in a temp I put up root arrow left. So whatever is root arrow left, okay, this is one of the implementations. You can use any other implementations. If you see some books or somebody writing different implementation, you can do that also. And now root arrow left means this guy, so that is saved in the temp, okay, the temporary pointer, and I go ahead and delete this. Now I don't worry about this because its address is in a temp. Okay, that's what I'm returning. I return the temp, which is the address of this node. Okay, so this will be fixed accordingly wherever it is called. Now if we have the two children, okay, so the first thing will be to find the in-order successor. Is it the smallest in the right subtree? So how we do that? We have min value, okay, and to the min value I will send root arrow right, because I go to the right side and starts finding the. So if I have here and like this scenario, and I'm here, root is here. Now I got to find in this guy the minimum value. So that means I got to send this address. Now this will act me as a root for the min value. Okay, so that is root arrow right. That will tell me this guy's address. Okay, and that will be sent to the min values node, and min value will come out with the minimum value, which in our successor of this node, and that thing will be loaded in a temp. Okay, so then we say that we know that we have to copy whatever the min value is here. For example, 90 was min value, we have to copy that here. Okay, so root is pointing to this, and now temp will be pointing to this. How? Because min value will take up find the minimum value and put the address of that into the temp. Now root arrow key should be the temp arrow key. Is it the temp arrow key, and should be put into the root arrow key, so it should be overwritten like we did here. So I'm saying the root is here, and the temp by the minimum function which finds the mean value, make the temp point to this. Okay, say for example it was something like 25. Now this is to be put here, right? So root arrow key equals to temp arrow key. That is here. That's what I do. Root arrow key equals to temp arrow key. Okay. Now you got to delete the inner successor. Okay. How you will call the delete function, the delete node. That's the same thing, the same function, this function. Okay. But here you are sending it not the root, but you are sending it root arrow right. You are sending it this address of this node. So we are trying to delete in this node now, this subtree. Now this is our subtree, and which one to delete is whatever the value of the temp arrow key is. So in this case here, now what we are doing is we are trying to delete in this subtree, in the right subtree, and with the value says for example 25, because 25 is copied here. Now this 25 should be deleted. Okay, so what we do is we call the delete function and send this address as a root address, start from this position, and now delete will find it wherever it is. Okay, this temp arrow key, that is the 25, and accordingly it will delete it in either this mode or this mode, or this is either the single child or no child type of deletion. Say for example in this case, when it is here, for example, I want to find 20, so I have an address that is 30. Okay, what is this? Is it 30 or 25? Let's make it properly now. Say for example we were here having 20, then here on this side 10, whatever it is. Now on this side was a 25. Okay, then that was this guy was, say for example 24. Okay, and this was 30, and you want to delete the 20. So what you got to do is, firstly you want to find the in this case we have two children, so to land the last it will land it here, so it will find the minimum value in our successor. So we are sending it the root arrow right, because root will be in the beginning on the top, this guy. So root arrow right, I'm sending this address to the minimum value. It will find me the 24 is the minimum, so it will put up the temp there. Okay, so temp is pointing to this. Now next thing will be root arrow key. So root arrow key equals to temp arrow key, that's 24 will be copied here, and now I have to delete the 24. So what I do is I call the delete node again. Okay, and I'm sending it root arrow right, that is 25. Okay, so in the delete now 25 will address of 25 will be sent to this, and temp arrow key, that is this 24 to be searched. So we have to search in this. So delete is again called, so this method will be called again and here in this root will be the address of 25, so root will be here, and key is now 24, which I want to delete. So it is searched. So we will land here, root is not null. Okay, now we see if key is less than root arrow key. Yes, that's true. Key is 24, 24 lesser than 25. Okay, so what will happen here is we say root arrow left equals, so we say this one, root arrow left, that means this in 25's left pointer. Okay, equals, and I do what here, I again call the delete node, I again call itself recursively and send the root arrow left now. So I'm calling again the delete function, and I send root arrow left, that is 24. Okay, now in a next iteration of this recursion, next recursive iteration, now what we say is we have the delete node, and now 24, this was 10, then 25 and 24 and 30. Now our delete will have a root address of 24 now. Okay, and key is 24 again, key also is 24. So we are calling it again, and send it root arrow left this time, and key. So root arrow left is which one? Address of 24. So root is, now when I call the delete function, I have in a root the address of 24, and the key is also the 24. Okay, now is root null? No, it is not. If the key to be deleted is smaller than the root key, okay, so here neither it is less than nor it is greater than, because it is equal to, this is the guy which I want to delete, so we will land here. Okay, that's what we say. If key is same as the root's key, then this is to be deleted. So we try to see firstly the node to be deleted now is again we try does it have root arrow left null? Yes, it has null, so it will go ahead and delete this node. It will free the root. Okay, it will free that 24. It will free 24, right? And whatever its root arrow left was, that is a null, that is put in a temp, and that will be returned, because that temp will have now the null in it. Okay, because root arrow left is null, that is we store in a temp, and that will return, and that will go into the this root arrow left. Okay, because we have called it where? We have called it here, right? We called this recursive function from here, so it returned me null, this delete node, and it is going to the root arrow left, and the root was there at that time pointing to the 25. Okay, so in this node's left will have the null in it. Okay, or if we have another scenarios, then it may go to the if that is not null, then it will go to the maybe others, and it will delete that. Okay, you can simply work it out. Now hopefully you got it. If you're not getting, just open up the copy and pen, start working on this. You will get it, inshallah. Anyways, this is the end of this segment. Till the next time, keep smiling, and ma salama.